Shilkuta ji, namaste.
Good afternoon, namaste.
Namaste, namaste. Very good. Anyway,
कैसे हैं साहब? How are you?
our campaigns are going on very well. Catch the rain, अच्छा चल रहा है.
Good.
33,000 crore work is going on, and a lot of good public feedback on that.
अच्छा. Okay. That's nice.
You were associated with the water mission earlier, ना? तो बहुत
For a few months, I think 7-8 months I was there.
Then we actually look at it, our webinars and all, we get 45,000, 50,000 people attending live.
Okay.
इतना popular हो गया, and these are all very highly look forward event. अब आपका what Tech Talk में काफी technical people जुड़े हुए हैं.
अच्छा.
And it's really good. And then every third Friday we have this water talk.
I know.
काफी लोग आते रहते हैं, and every Saturday we have meeting with DMs. हमेशा कुछ ना कुछ होते रहते हैं.
That's really nice. You have made it very popular, all these things.
So we are going live just in we're on mute mode, and I'm going for live Facebook.
Fine. Everybody, take it. Fine. Anupama is joined. Who joined?
Yeah, sir. No, sir. I'm here. Yeah,
very good.
Shall we start, sir?
Go ahead.
Yes, you can start.
Good afternoon, everyone. I welcome you all in today's 11th Water Tech Talk, being organized by National Water Mission, Ministry of Shakti, and supported by Water Digest. I also welcome you, Shri Sushil Gupta, member PWRDA and former chairman CGWB and CGWA. And today's topic of the 11th Water Tech Talk is identification of arsenic-free aquifers and technology for constructing arsenic-free tube wells. Now, any further delay, I would like to invite Shri G. Ashok Kumar, Additional Secretary and Mission Director, National Water Mission, to kindly propose the opening address. Over to you, sir.
Thank you, Neha. Thank you for the introduction. Welcome everybody for this 11th Water Tech Talk, which we had started on 9th October 2020 onwards. And we have had very, very prominent speakers talking on various aspects of water technology related in waterfront. And we had people from Israel, from the companies telling on various aspects of the various cutting in technology availability. We had people from academic side like Dr. Pradeep from IIT Chennai, from Dr. Nupur Bahadur, fellow of the Terry Institute, who talked about the wastewater treatment. We had Dr. Ashwagosha Ganju from the SASE DRDO, who talked about the determinants of snow, ice, water resources, sustenance of the Himalayan sector. Dr. Bhishma Kumar, former professor and staff of IAEA, on the isotope application of water resources. Dr. Deepak Kashyap was the last speaker who talked about the advancement of the groundwater management practices in India. So, variety of topics, variety of aspects of water technology related issues, variety of innovative things. Dr. Indersen talked about the quality testing of water, and then about the generation of water from air by Dr. Pradeep. So different cutting edge technologies we have discussed, and that's why we are thankful that we have very large dedicated viewers of this Water Tech Talk, and very high quality people from various institutions attend this program. It's very, very heartening to see that. And now I'll take 2-3 minutes to mention about the campaign which the Honorable Prime Minister had launched on 22nd March. We had National Water Mission had started this campaign with the blessings of the Honorable Prime Minister on 22nd March. The Catch the Rain campaign, Catch the Rain where it falls, when it falls, basically addressing two major issues of the country. One is that a lot of water when it rains goes waste because of the porosity of the ground soil because of urbanization, because of concretization, because of tiling of the area, and because of the intensity of rainfall increased, and sufficient time is not there for the water to soak down. So all these has led to faster runoff, which has led to poorer storage of water and the depletion. And because we also use a lot of water, take up a lot of water from the groundwater. In fact, India is one of the largest 25% of the world's oil of water from groundwater is done by India. We do much more water from the ground, much more than America and China put together, because a lot of water irrigation is on groundwater. We are exploiting a lot of water, but never putting it back. So this replenishment of water is not taking place, and because of that, our water tables are going down. And because of that, we require more powerful motors to pump up water. We require more fuel to pump up the water, which in turn causes climate issues of global warming, etc. Because a lot of energy has to be used for that. And second is, as I said, when the water high intensity water rainfall causes a lot of water to come in, and there's less permeability. All this water flows down to the low-lying areas, creating havoc by creating floods. So urban flood has become a very recurring phenomenon now. So these two things are primarily addressed by the campaign, which was launched by the Honorable Prime Minister with the tagline "Catch the rain where it falls, when it falls." It's basically a decentralized storage of water, and let me tell you, it has been extremely heartening to see the progress which we have done. We have actually in the last 3 months done more than 35,000 crore worth of work. Almost 17 lakh water harvesting structures have been constructed all over the country, and some at 10 lakh work is going on both in rural and urban areas. A phenomenal number of tanks have been restored and rejuvenated. This is a very successful campaign which we went. That also brings to the another interesting aspect of increasing water table in the ground also reduces the arsenic. This is a very strange study which we got it from the Hyderabad universities. JNTU had been doing this rainwater harvesting structures, and the Nalgonda area, which is known for fluorosis. They have in the last video talk with the governor and us, they informed that because of the replenishment of water, or the dilution effect has taken place, and the arsenic or the fluorosis concentration has come down. So probably catch the rain also would be a solution, a little bit of a solution for reducing the arsenic concentration in the ground. So it would be helpful. And today's topic as discussion is on the arsenic, how to manage arsenic in the water. Is a very contemporary topic, because overexploitation of water, groundwater, has led to more arsenic concentration in water, and more areas coming under the threat of arsenic pollution. And the effect is that there are villages which have almost as high as 1,310 microgram per liter. That is 1,310 parts per billion arsenic in Chaube Chapra village in Bellary block, where when the accepted is only 10 ppb, whereas 10 parts per billion is the accepted concentration of arsenic. We have some villages having as high as 1,310 parts per billion. So this is a big challenge. The area number of villages getting affected by arsenic also is growing up, and there are low-cost technologies coming out. So that I think Mr. Sushil Gupta will talk about it. He is a groundwater expert. He will talk about it. That is the background of today's discussion. So let me introduce you to the speakers. Today's speaker is Mr. Sushil Gupta. He is a groundwater expert, and having served in Central Groundwater Board and Central Groundwater Authority for over 37 years, he superannuated as chairman in 2014, and at present is a member of the Punjab Water Regulation and Development Authority. He's technically extremely sound person, deep knowledge on the subject, domain expert. He has more than 50 technical reports to his credit, and also a chair or member of various technical committees associated in the national level, and contributed to many scientific papers. He also joined as a consultant in the National Water Mission for some time, and then with the World Bank as a program development specialist. He was actively involved there in the program formulation of National Groundwater Management Program, now known as the Atal Bhujal. So ever since he has been appointed as the member of the newly created Punjab Water Regulation Development Authority in August 2020, and is very actively engaged in developing various programs for appropriated management and regulation of water resources in Punjab state. Man with tremendous domain knowledge, domain expertise, and will be talking to us on a very important topic related, a contemporary topic related to arsenic and water management. Over to you, Sushil Gupta ji. We have a good audience, a very highly technical audience, because this water tech talk is meant for people who are technically and oriented, technology oriented, and when they have the water talk where we have people on janta jud jata hai, but this is a highly focused people from good universities, from technical institutions, premier institutions like IIT Roorkee, IITs, and other technical institutions. Students also join us up. So they are all waiting for your talk. Mr. Sushil Kumar, over to you now. Thank you.
Yeah, thank you, Mr. Ashok Kumar, and good afternoon to you, Mr. Ashok Kumar, and all the participants. And thank you so much for such a kind introduction. Yeah, thank you so much. It is really a great initiative on the part of National Water Mission. Mr. Ashok Kumar and Dr. Teck Singh, scientists, who have initiated this tech talk. In fact, I was also in National Water Mission in, I think, in the year 2015. So at that time, we did not have such good ideas and talks taking place. So okay, anyway, it's really gratifying to have been invited to deliver such an address to such a large and knowledgeable gathering regarding my field experiences. The talk that I'm going to deliver is based on my personal experiences during field visits to Balia in the year 2005, when I was posted in Lucknow, and CGWB, that is Central Groundwater Board, at that time was undertaking a project to help the state government in arsenic mitigation through supply of arsenic-free groundwater for drinking water purposes. So at that time, the situation was really very grim in the district, and it was really something I would say that CGWB did a very good job, as I'm going to outline in the following presentation and the slides and the talk that I'm going to discuss with you. So just to make a just to give you an overview of arsenic contamination, which is also a very big health hazard in most of the parts, especially in the Ganga, Brahmaputra, fluvial and floodplains, falling in West Bengal, Jharkhand, Bihar, Uttar Pradesh, then Assam and Manipur. And in the hard rock areas, it is not that prevalent. It's sporadic in nature, especially you find it in Rajnandgaon area of Chhattisgarh state. And arsenic-3 is highly toxic, as is arsenic-5, the pentavalent form. So these are the two forms of arsenic that are really toxic in nature. So when we So as you can see, UP is one of the northern states of India, and Balia, out of that, Balia is the easternmost district of Uttar Pradesh, and it is an area of about 3,000 square kilometers. It is divided into 17 blocks, as you can see by the different colors that are displayed here. And the normal annual rainfall in this area is also good. It's about 950 millimeters, out of which about 800 and odd occurs during the southwest monsoon. That is from June end to September end. And incidentally, here also, as in most parts of the northern belt of our country, almost 90% of the area is irrigated through groundwater. And also 90% of the drinking water supplies are also through groundwater. That is why it's very important that in this area, any issues that are concerning drinking water need to be sorted out, need to be looked into, and especially arsenic, which was reported some time back. Now, if you see the geomorphology and drainage of the district, so on the northern side, the district is bound by the Ghagra River, as you can see, and on the southern side, you have Ganga River. And at the eastern end, both rivers, there is a confluence of both the rivers, and naturally, then this area is the interfluvial area. The entire district is an interfluvial area. The gentle slope it is sloping towards southeast, towards the confluence. And physiographically, we can divide this into two areas. That is you can see the light yellow color on your right side, that is called as the lowlands. And on the left side, the orangish color is the uplands. Uplands have a general elevation of about 65 meters above mean sea level. The lowlands about 50 meters above mean sea level. And the upland has by and large an even topography, whereas the lowland areas have highly rugged and uneven topography. And also, the lowland is characterized by marshes, the blue areas that you can see, marshes, swamps, lakes, oxbow lakes, etc., etc. This is a hydrogeological map. You can see there are two major colors. One is the yellow, and the other is again on the pinkish side. The yellow is the younger alluvium, which is occurring almost along the river. And then there is the inner older alluvium. Then along the river or in the river courses, we have floodplain deposits also, which are restricted all along the river channels. So mostly these are covered by the present river and adjacent smooth plains. These comprise mostly coarse sand deposits with some silt and clay. The sandbars, abandoned channels, levees, landforms are very common in this area. In the newer alluvial plain, it is the old floodplain cycle of the deposition by the rivers. And this also consists of similar sediments, which are slightly finer as compared to those in the flood courses of the river. And then the older plains. If you see the surface water divide also runs along this axis, and the groundwater divide also runs along this axis. The groundwater in the northern side is flowing towards northeast, towards Ghagra River, and on the southern side is flowing towards southeast, that is towards the Ganga River. The general flow direction of groundwater is towards the confluence, that is towards the east. And in the older alluvium, the quality of water is also slightly brackish. That is, you get EC, electrical conductivity values up to about 1300 to 1400 EC in the older alluvium, and some areas, sporadic areas in the younger alluvium. Central Groundwater Board has, not during this project, but earlier during the normal exploratory program in the country in the alluvial area, has carried out drilling in this area also up to 750 meters below ground level. During the current project, which I am going to talk about, the drilling was only up to about 350 meters. But earlier, up to 750 meters drilling has been done, exploration has been done. And as is prevalent in the central Ganga plains, this area also has a 3-tier aquifer system. As you can see the fence diagram, the first aquifer generally is the water table aquifer and down to about 130 meters BGL in the western parts of the district, and it extends to about 150 meters BGL in the eastern part. That is, in the eastern part, the water table aquifer is slightly thicker as compared to the western part. The second aquifer group extends from 119 to 180 meters BGL in the western part, and from 86 to 294 meters VGL in the eastern part. As you can see, the extension of the individual aquifer group is variable over the district. The thickness, the extension, and everything is variable over the district. The thickness of clay beds also is much more in the western part as compared to the eastern part. And the clay beds generally merge into the granular beds towards east and northeast of the district. So, as I'll tell you later also, there is hardly any good clay, plastic clay or any good clay towards the eastern part. And the clay beds here do not form a very good confining layer also. So, aquifers, though they are, as you can see in this slide, the shallow aquifers are under water table conditions. But the deeper levels, it occurs under semi-confined to confined conditions. Most of them are, I would say, semi-confined rather than confined. The depth water level in the central part is between 2 to 5 meters, the green color, and in the eastern and western part, they are 5 to 10 meters below ground level. The pre-monsoon map is on the top, and the post-monsoon map is on the bottom. So during post-monsoon, naturally the area under shallow water slightly increases. The yield of wells tapping shallow aquifers is quite copious. We get up to 100 LPS with very small drawdowns. The specific yield is also good, about 12%. And up to the depth explored, we have not encountered any bedrock till 750 meters. That means the thickness of the LUM is quite large over here. The chemical quality is by and large good, except for sporadic occurrences of slightly high EC water in the older alluvium. Chloride, etc., everything is good except for arsenic, which is high, as we'll discuss in the coming slides. This is the interesting part from where the story begins. On the left side, if you see, we have a father and son duo. Both have skin lesions on their chest, and the younger son, the lesions have started to develop. Maybe they are not very clearly visible in this particular slide. All these photographs, entire photographs in this presentation have been taken by me. This is a gentleman by the name of Mr. Dinanath of Rajpur, Ekona village. This photograph, 2003, he is an ex-serviceman, retired from military. His village is Rajpur, Ekona. After his discharge from duties, he came to settle down in his village to till his small farmland. Gradually, he started developing some skin rashes. He didn't mind in the first instance, then gradually they increased, so he went to the local hospital, and there they gave him some anti-allergic medicines, etc. Didn't cure him. Then he went to the district hospital. Again, they gave him some medications. While all this, few months passed, but his itching and everything kept on increasing. Then he went to Lucknow Medical College, which is the state medical college of Uttar Pradesh. There they suspected that there's something wrong. It was beyond their understanding also. So he was referred to All India Institute of Medical Sciences, New Delhi. Whereupon, after doing a detailed analysis of his samples, they took samples of his hair, his urine, blood, etc., etc. They realized that the gentleman is suffering from arsenic. The arsenic levels in his blood at that time were about 34.4 micrograms per liter, or parts per billion. Billion is by B, not M, parts per billion. So, as Mr. Ashok Kumar also said just now, the limit is 10 parts per billion. So, he was having almost 3.5 times more arsenic in his body. While all this was going on, he started developing major ulcers, etc., on his fingers. And ultimately, he lost, as you can see, he lost 2 of his fingers due to arsenic. So I would say that this is the gentleman who heralded the news that yes, there is something wrong with the groundwaters of this area, because there was no surface water supply. They were all drinking water from dugwells and hand pumps. So it was concluded that groundwater is the issue, and that is how the alarm was raised in this particular area. Now, all this happened in the year 2003 and around that. Now, At the same time, incidence of high arsenic was also reported in the adjoining areas in Nepal. So all this led to many news items, magazines, articles, etc., and because of which the Sri Ram Institute carried out analysis of about 3,400 samples collected from 10 districts in the entire Uttar Pradesh. Not only Balia, entire Uttar Pradesh. At that time, this study revealed that about only 4.3% samples out of, I said 3,390 samples, or only 4.3% were having arsenic more than 10 ppb. And only 0.1%, that is just 3 samples out of 3,390, had arsenic more than 50 ppb. So this led to further investigation because this was for entire Uttar Pradesh. So people wanted to narrow down as to where the problem is. So in the year 2004, Jadavpur University from Calcutta sampled about 2,400 hand pumps in Balia district and reported that almost 55% samples contained arsenic more than 10 parts per billion, and almost 36% contained arsenic more than 50 parts per billion. So this was really alarming, saying that almost, you can say 90% of the samples collected had arsenic more than the permissible limits of drinking water as per BIS. Now this is another gentleman. I've taken a close-up of his hands. He had started developing all these skin rashes and everything. It's a very sad condition. I have visited so many houses over there. Really very sad. Now, as I talked earlier also, the drinking water standards prescribed earlier that the limits would be 10 parts per billion, which could be extended to 50 parts per billion in case there was no alternate source. But later on, the standard became strict, and as per amendment in 2015, the relaxation was withdrawn, and now you can have arsenic only up to 10 parts per billion in the drinking water supplies. This is a limit which is being followed by WHO also. So, as I said, that the arsenic problem was detected, or you can say reported, whatever way we want to take it, nearly about 20 years ago. Then CWB was brought into the picture, and CWB also carried out a preliminary study before going into the project, jointly along with UP Jal Nigam. And we realized that out of the 17 blocks, 12 blocks are mildly to severely affected with arsenic contamination. And out of these, 5 blocks have a very high percentage of villages with high arsenic. So as you can see, again, Mr. Ashok Kumar mentioned in his introductory remarks that arsenic up to even 1,310 ppb was also found in one of the villages. Yes, he's very correct. This was very, very high in Murli Chhapra block of Balia. So as you can see, the blocks in orange on the extreme right, these are 5 blocks in orange color, which are highly affected blocks. The green blocks in the newer alluvium are by and large not affected. The yellow blocks are moderately affected, and the pink blocks away from the confluence of the two rivers are slightly affected arsenic blocks. So this was the status when we on the basis of our preliminary studies. Now again, UP Jal Nigam in Balia collected almost 5,651 samples for a detailed analysis, and the samples were analyzed by using National Chemical Lab field test kits. Now, field test kits is for a blanket analysis of the water samples, and the hotspots identified on the basis of these field test kits are then resampled, and the samples are then analyzed by sophisticated methods in the laboratory. So this primary testing was done to identify the hotspots in the district. Now, they wanted to test almost 10 to 15% of government sources of drinking water supply. What they did was that they tested one sample from those habitations where 10 or less than 10 water sources existed, and 2 samples from where the water sources were more than 10. The results, as you can see from this table, the first thing is up to 10 parts per billion, almost 73.6% samples had arsenic less than 10 parts per billion. So they were clear, no issues with that. Almost 19 or 20% samples had arsenic between 10 and 40. Just about 2.5% between 40 and 50, and about 4% above 50. So in a nutshell, you can say that about 26-27% samples had arsenic higher than the drinking water limits. But at that time, when this blanket survey was done, the allowable limit was 50 ppb. So as such, at that time, only 4.35% samples in Balia qualified for the high arsenic zones. Now, when CWB came into picture, so the first job was to identify the hotspots, that is villages having more than 50 microgram per liter or ppb. To also study the extent of arsenic contamination in different aquifers up to 350 meters. As I said earlier, though CWB has done work up to 750 meters, but during the time when it was done, at that time there was no arsenic studies going on. So we did not really monitor the chemical quality pertaining to arsenic or take any specific steps to measure arsenic in the different aquifers. But now, arsenic specific studies curtail the depth of further investigation to 350 meters, and also to ascertain whether there is arsenic in the deeper aquifers also, or they are arsenic free. And once we start developing these arsenic free aquifers at the deeper levels, whether they will remain arsenic free over a period of time. So what will happen if we keep on pumping these wells, or for that matter, drawing water from these aquifers? Then also develop a standard and innovative design for tube wells, tapping arsenic-free aquifer and ensuring that the arsenic-infested water or the arsenic-free water does not get contaminated by a vertical flow of arsenic from shallow aquifers to the deeper aquifers. This is very important. And also hand over the arsenic-free tube wells to the drinking water supply department, and ultimately transfer the technology, train the people over there to do everything themselves. This was the basic objective of CGWB at that time. So when CGWB collected its own samples to carry out its study and identify the hotspots, we collected about 144 samples, 9 from dug wells, which were less than 15 meters in depth. Then they had the number of private hand pumps, which were generally in the depth range of 15 to 40 meters. So 48 samples were collected from those structures. Then we had India Mark II hand pumps, which are generally constructed by government agencies. They were by and large in depth range up to 70 meters, but most of them were about 50 meters or so, I would say. So 69 samples were collected from such hand pumps. The state government was already supplying drinking water. 15 such state tube wells were identified and samples collected, and we had our CWB exploratory wells constructed during previous years, earlier years. So in the depth range of 289 to 546 meters. So we had 3 tube wells in that area. So total 144 samples have been collected. And if you can see the results, by and large, no detection of arsenic was there in about 8% samples. So dug well and hand pump, shallow hand pump, they all contained arsenic. There was no 0 sample which did not contain. 11% hand pump Mark II contained, 8 samples did not contain arsenic. 1 of state tube well did not contain, and none of the CW tube wells contained any arsenic. Majority of the arsenic was found in the hand pump samples, You can see 10 to 50 is the column of denoting 10 to 50, and hand pump, private hand pumps 25%, and more than 50 ppb 54%. And similar, the India Mark II hand pump 33% and 46%, and CEWB 0%. Even the state tube, which is 70 to 100 meters deep, it was surprising that we found 67% and 30%, so almost 80% of the samples, or rather having arsenic content more than 10 or 50. So this might be due to the fact that they were not constructed properly, and there was arsenic contamination from the shallow aquifer going down this particular aquifer which they were pumping. And as you can see, the hand pump, the right column, the rightmost column, range of arsenic concentration. The private hand pump, which is 15 to 40 meters deep, that had the highest concentration of 1310 ppb. Otherwise, the general range was from 2 to 685. The India Mark II hand pumps, the highest concentration was 685 ppb, where the general range was up to 345. And the state UL, the highest was 64. The general range was from nil to 45. So this gave a very clear picture as to what is happening over there. And one thing, what my experience, and at that time, after lots of discussions with my chemists in my own department and various CSIR labs in Lucknow, we have Indian Toxicology Research Institute Center and things like very advanced research center. It was ascertained that it is very important to follow a very proper and rigid protocol while collecting samples for arsenic. Number one, after following that protocol, it is also necessary to observe correct procedure for analysis while utilizing a proper instrument. So we did all that, and the water samples were collected in pre-treated 1 liter polythene torsion bottles after being filtered. All the samples were filtered right there at the site. I'll show you in the one of the photographs. Through 11 micron filter paper. The sample was filtered there only, then treated with analytical hydrochloric acid. And then these samples were brought to the lab in Lucknow and analyzed for the estimation of total arsenic on a AAS using HPG, that is hydride vapor generator. And it was a Japanese instrument, Shimadzu, some model was there. And the methodology for analysis was as per APHA 19th edition, which was at that time the latest way of doing the analysis. So the result of the analysis was that this map shows you from where the samples were collected. The round one is the hand pumps, India Mark II. The triangle, blank triangle is the state government tubes. These were the existing exploited tubes of CWB done during the earlier years. Then this round, you see, these were the exploited sites that were now proposed for these studies that CWB will not take up here. And these round circles below on the slide, you see the green circles is where the arsenic was less than 10 ppb. The blue circles denote arsenic was between 10 and 50 ppb. And the red circles denote arsenic was more than 50 ppb. So this gives a very clear picture that where you see the red and the dark blue circles, they're all concentrated towards this rightmost, easternmost part of the district where the major problem lies in this area. Now, again, this is the same thing represented in a slightly different way. I have plotted here an inset of the hydrogeological map, which I showed earlier. You see the yellow one is the younger LUV. And all your major, it's occurring here. And this is the, again, younger LUM area where the major arsenic problem is occurring. So these 7 blocks are Belhari, Beria, Rayoti, Murli Chapra, Dubad, Bansdi, and Maniar. So these are the blocks which are highly affected. and arsenic is confined mostly to the shallow aquifer of this near the confluence of the younger Elbe. As you can see, hotspots were identified based on all these studies, the hydrogeological studies, hydrochemical studies. We consulted the state government data. Based on this, we selected 11 sites spread over 9 blocks for studying in detail through exploratory drilling. These sites are marked on this map with red color. These are the 11 sites where we decided to carry out exploratory drilling and associated studies for arsenic studies. The drilling was taken up to 350 meters, established the variation in arsenic content in 3 aquifers. As I said earlier also, we have a 3 aquifer system by and large. 3 wells were constructed at each site, tapping individual aquifers out of 3 groups. Then we have provided a cement seal against a clear horizon in the annular space by designing the well assembly so that there is no vertical movement of arsenic. I'll show you this in the detail in the next slide that will make it much more clear. So this is the schematic diagram that I made. Now, if you first see it on the extreme right, there is a lithology that has been plotted. The blue color on the top is this aquifer which is rich in arsenic. Then we have a clay which is separating the arsenic-rich aquifer from another aquifer down below which is arsenic-free. Then another clay, and then you have another aquifer group which is arsenic. So this is the 3 aquifer group system which is by and large prevalent in this part of the Ganga basin. First aquifer, second aquifer, third aquifer. The first is full of arsenic, it does contain arsenic. Second and third are arsenic-free. So what we do is, the first thing is that when we have drilled the borehole, samples are collected, the cuttings are collected while they are coming out, and a litholog is made based on the cuttings and the depth drilled when sample is collected every 3 meters. So once that litholog is prepared, after that the hole is, because it's a mud drilling, the hole is washed and we carry out the electrical logging of the borehole, so as to obtain the electrical properties of the lithology of the aquifers, which basically in this area we want to decipher the boundaries between various types of formation, that is sand and clay, by and large, sand, silt and clay. And also, of course, it gives us an idea of the quality of the salinity of the formation water. So after that, once the logging is done, we prepare a compromised litholog. That is while taking into consideration the drill cutting litholog and the indications of the formations and the exact boundaries litholog. We compromise both the things and come out with a final litholog. On the basis of that, we design the well assembly to be lowered in the borehole, where the slots are going to be, where we want to put a cement seal, where we want to fill it up with clay, etc. So once we do that, we lower the assembly into the borehole. We also place centering guide so that the borehole doesn't become crooked. So otherwise, it will be a problem. It will touch the wall and we won't be able to feed gravel into that particular part. After lowering the well assembly, when we have lowered the well assembly, fill up the borehole with gravel up to the place where you want to place a cement seal. But one thing that we did over here, the new thing, apart from cement seal at proper location, was wherever I want to place a cement seal, I will fill the gravel only up to 3 meters below that and fill that top portion with clay before pouring in the cement. Because cement is likely to go into the gravel and also seal my slotted pipe. So I always got a 3 meter thick clay zone inserted here and just below the cement seal. And after that, cement seal was put and the borehole was given a rest for about 72 hours so that the cement should settle down. Before placing the cement and the clay, while the graveling was being done, all the time the whole fluid is continuously into circulation so that the gravel does not form a bridging and it is well settled into the borehole. And there is not much of cuttings left in the borehole. After the cement seal is set for 72 hours, we again fill the borehole with clay. And since these are all drinking water wells, we provide a sanitary seal. This is also cement seal, but just below the ground level. Again, a 3 to 4 meters thick cement seal, or as a sanitary seal, is provided. Now, we also make a provision for a tremie pipe. This you see on the right hand side is a thin pipe which goes from the top above ground level down to the gravel zone. So that in case there is any bridging of gravel, the gravel settles down after some time. We can feed gravel at a later stage also into the annular space. Now, this design ensures that any arsenic laden water from this particular topmost aquifer does not go down along the gravel to the aquifer which I am pumping. This is most important. As I said earlier, the state government tube wells, we are finding arsenic in the water, which the tube wells were about 100 meters deep. Whereas our studies confirmed that the arsenic is not there after about 60 meters. But their tube wells did contain arsenic. So the only likely cause is that they were either tapping all the aquifers that they found in this area because they were not aware of the arsenic contamination. So right from top to bottom, they in the 100-meter tube well, they tapped all the aquifers. Or even if they didn't tap, they didn't provide any sealing, etc., so that the arsenic from the top aquifer traveled along the gravel and into the pumping portion of the well. That might be the only reason that I see for getting arsenic in state government. So after we do all this, then the well is developed first with the compressed air, and then we develop it with a pump over development so that the well is ready for being tested. Then we carry out a step drawdown test to ascertain the efficiency of the tube well and the formation, etc. And after that, aquifer performance test to assess the various hydraulic properties, their transmissivity, etc. So that is how we have constructed all the wells in this area by following this procedure by and large. Now I'll show you some pictures. These are our drilling sites over there. Just on the left, this compressor development is going on. You see this white jet. This is water coming out of the tube well during development. On the right, you find officer collecting samples for arsenic. This is Mr. P.K. Tripathi. He is our current regional director at Lucknow office. So he is, if you see, I don't know whether you can make out or not. He is filtering the sample through a filter paper right in the feed and collecting in these torsion bottles. Now, as I said, we log the borehole and we prepare a compromise. These are some of the lithologs, etc., that I'll show you. This site is Dalan Chapra. This is block Murli Chapra. So this is the composite picture of a particular site, wherein this is the on the extreme left is the compromised litholog after considering the drill cuttings and the electric log. This is the electric log. On the left is your SP log, that is self potential log. To the right is your normal resistivity log. This is in two. One is 16 inches, the other is 4 inches. So this gives you the resistivity profile of the formation water vis-a-vis the formations, and this gives you self potential. So interpretation of these gives us the for this area where is clay and where is the sand horizon. One more thing is let me see just a moment. Yeah, normally what we do is that in such areas where before lowering of the well assembly, we want to test the quality of the formation water. In this case, we want to test for arsenic. So what we do is we do not lower the assembly as such. We lower a temporary assembly and seal it with a backup. I cannot open that, but anyway. So that's a locally designed equipment, which it's a conical kind of thing which you put it on a pipe, and we ream the borehole to the particular depth and then fit the packer there and run the compressor. But for that, you need a very good clay in the lithology, so that against that clay we fix the packer and draw the water from the desired zone. But in this area, as I said, so there is hardly any good clay. Clay is all mostly silty or sandy. There is no pure clay. So we could not find any clay horizon to fix our packer we did try 2 locations, if I remember correctly, and both the places the packer leak, that is the formation collapsed and the water and air started coming from the side. So we could not isolate the zone. So instead of doing a packer test, we decided to construct 3 wells at each side. First, the shallow one, so that we could test the quality. Then the medium one, and then the deeper one. So they were all constructed in succession. So if you see here, in this particular Dalin Chapra, which is in Mundi Chapra, the total depth drilled was about 348 meters. And in the deep well, this one is a deep well, we tapped 4 zones, 1, 2, 3, 4, in a depth range of 186 to 276 meters. Then a 4-meter thick cement seal was provided here from 151 to 155 meters. And the rest of the borehole was filled with clay. And in the medium observation well, we tapped at 2 places and provided a cement seal at 56 to 60 meters. And in the shallow one, there was no cement seal because this was the arsenic aquifer. This was only for testing of the sample, as well as when we carried out a pumping test of this well, we wanted to see whether this has any connectivity, whether this deeper aquifer below which we have tapped has any connectivity to this or this aquifer, whether any reaction in the water levels is happening or not. So that was the basic purpose. After that, the shallow well was capped. It was not left open for anyone, and these 2 wells were handed over to the state ground agency for their drinking water supply purposes. So similarly, we have, I'm showing you just 4 or 5. This is again a site in Ramgarh. This is in Varia block. Here also, here if you see, we constructed the shallow and the medium observation in one hole only to save space. So this is again similar thing as I said earlier also. This is the third site. Here we constructed only one observation well. This is the fourth. Again here we constructed in the same borehole 2 wells, and there was a cement seal provided for the medium zone. Apart from the deeper well also cement seal was provided. So these are the results which we obtained at these sites. You see, Ramgarh, which was in Baria block, these are the range of zones tapped. This was the depth of the well. This is the cement seal where the cement seal provided, and what is the arsenic concentration. So by and large, the only surprising part was that we found arsenic in this medium well of 89 meters depth in Chan Chapla 25 ppb. This is, I have not been able to explain to myself. Maybe there was some fault in construction, or maybe because arsenic is not really 100% guaranteed that it will be only in the shallow aquifer up to 60 meters. Maybe it was because of that. So otherwise, all the other, I'm giving here data of only 5 sites. All the 11 sites were arsenic free, the deeper wells. Only this particular one well, medium well, was having some arsenic higher than the limits. So if you see the results, the arsenic content is high in the first shallow aquifer, though not universal, that all the shallow aquifers have high arsenic concentration. This aquifer, especially comprising of the newer alluvium, occurs mostly along the river courses. The shallow aquifers in the older alluvium and the deeper aquifers all over the district are by and large arsenic free. Design of the wells and placing a cement seal against a clear horizon just below the first aquifer does not allow the arsenic-rich water to percolate down along the gravel path and contaminate the deeper aquifers. Even after long duration continuous pumping of 1500 minutes. We carried out pumping tests of about 1500 minutes on the deeper wells over there, and there was no contamination of arsenic even after so much of pumping. So we have handed over this technology to the state government, explained to them all the ways it's to be done. And residents are now, because of this, getting arsenic-free water supply. So that is, I think, all. Yeah, thank you. And happy Independence Day to all of you.
Thank you, Shakti. Okay, we'll open up for questions now. It's very good, very good presentation. So let's open up for questions.
Thank you, sir. Thank you so much, sir. And good afternoon, everyone, once again. Before proceeding further, I would like to introduce the format. To ask your query, please click on the icon which is available on your screen. Raise your hand. Once you raise your hand, please wait for your name to be called. Introduce yourself first and your organization name to ask your query further. Sir, we have received one query in chat box, which is from Mr. Paritosh Tyagi, and it's related to the presentation only. And he wants to know, is the seal made of cement or cement mortar?
Yeah. Can you repeat the question, please?
Yes, sir. So his question is, it's related to your presentation, and he wants to know, is the seal made of cement or cement mortar, which is used? Mr.
It's
Paritosh Tyagi wants
It
to
is cement mixed with gravel. It is a quick settling cement, and we mix it with a little bit of gravel to make it hard. Can you hear me?
Yes, sir. Yes. Okay. Now I request Mr. Indra Sen, you may please ask your query.
Yeah, sir, this is Indra Sen from IIT Kanpur. Thank you so much for this nice presentation. We are also working on arsenic and as well as uranium. Of course, I know the presentation is with arsenic, but lately we saw a lot of uranium in this alluvial aquifer and not arsenic, and both are geogenic source. So that's my question. What's your take on uranium? Of course, it's not arsenic, but they are very similarly geogenic in nature. And second of all, what sort of field testing is being done? I know there are a lot of field tests available, but how accurate they are, because the one we have used, they are not really trustworthy. That's why Kent has given us a large project to develop field test kits for your testing arsenic. So these are my two questions.
You see, as far as uranium in alluvial soils is concerned, I have not done much studies, but as I understand, uranium is already there in the background in soils. Now, if you see the soil profile, you will find uranium in a geogenic form. Now, as in arsenic also, you see arsenic is per se not there in the sediments as such. So it is the enrichment of arsenic which is more important. That leads to it being released into the groundwater. Maybe something like that in uranium also might be happening, though uranium in soil is there already present. In Punjab, I know it is present in the soil, but maybe it is getting enriched because of certain thing and getting developed in certain pockets. So that might be the reason. That is about uranium. Regarding the field test kits, I'll tell you a very interesting example. I did not mention it here. In my opinion, field test kits are not accurate, as you said yourself also. Now, there was a task force set up in UP when I was there by the UNICEF. And in my very first meeting, I found that the analysis based on field test kits is virtually each and every district of UP was infested with very high arsenic. And they were going to release that report in the public. So I asked the veracity of that report based on the accuracy of field. What is the accuracy level of these field test kits? Because if you release a report and later on we find that this is not correct, there will be such a hue and cry in the public. And we realized that the field test kits were very much off, very much off. Number one. Number two, then you see it also depends on what you are like. Arsenic is very delicate element. Now, even if you do it with the spectrophotometer, the results are very erroneous, very erroneous. So, if you are developing a field test kit, I don't know how you can make it more accurate, because ultimately the costing also has to be within the reach of that. But for blanket studies, I don't know, very frankly, this instrumentation of field test, how it can be done, what can be done to. You are doing it for uranium, I believe.
No, actually, we are doing for arsenic. That's an ongoing
Acha.
R&D project. But
Okay.
they want us to develop or a chemical molecule which will only react with arsenic.
Okay.
But
Okay.
arsenic is in +5 state, +3 state. That's even more challenging.
Yeah.
So
And
that's
these
why.
are these are two valences which are required to be tested. In fact, the total arsenic rather.
Yeah. But we are very
So
close, so I think we would be able to deliver very soon.
yeah, that's good. That's good because arsenic has been so widely studied, especially in Bangladesh.
Yes.
So we have had projects since I think almost 20 years. Very huge projects are there.
Okay, thank you so much, sir.
You're most welcome.
Thank you, Dr. Anderson. So how is your test kits working? Because you had developed those test kits. How is it in the market now? Is it available in the market?
Yeah, so sir, it would be very soon available. So glad to let you know we won the Jal Jeevan mission. I think maybe you are there, you already know. So we won it, and the product would be launched in October. So we are very close.
Actually, Shishupati, our Dr. This Chekasen was one of our speakers for the fifth water talk, and he had a
Okay.
very interesting water testing case, and which really using the resins. You
Uh-huh.
water with a small water bottle, shake it, and then pour the water out. And it reduces the volume of water to be transported for testing the quality. It is an amazing thing which intelligently developed by them. But that's something. And I keep on telling your product everywhere, Dr. Sen, telling that this is something which is a remarkable invention of Indian scientists. So I'm very happy with that. Very good.
Thank you so much, sir.
Next question.
Our next query is from Mr. Abhishek, and he wants to know how do you plan to emphasize the importance of arsenic-free aquifers to cities?
Sorry, I didn't understand the question.
How do you plan to emphasize the importance of arsenic-free aquifers to citizens, normal people?
Arsenic-free aquifers in
To citizens.
citizens.
Yes.
No, this is basically you have to have a huge mass awareness campaigns and not allow them to use hand pumps, etc., which are drilled in the arsenic aquifers. So, in Balia, at least I know most of the hand pumps were painted red, which were containing arsenic, and sometimes they removed the handles also of those hand pumps. But yes, mass awareness is required, a lot of mass awareness at the public level, so that people become aware which water to use and which not to use. And once you have a 24-hour or whatever it is, assured water supply through the water supply agency like Public Health Engineering Department or etc., they are giving you safe water at good times. So why would I go for a hand pump water on my own? Normally not.
So the problem is water supply.
No, I can't.
Many places the water supply from the surface water is all right, but many places the panchayat or panchayat department or over tanks and all, they get water from the underground. They pump the underground water and then store it up and then distribute to pipes. That area will be a problem of concern. If you are using surface water, probably you may not get into the problem of arsenic.
No, arsenic also, sir. In case you are pumping from an arsenic-free aquifer.
Okay, that's all right. Okay.
Then
But surface water does not have it. No? The surface water, does it contain this arsenic?
Normally not, but yes, it can contain. It can contain. I think Bangladesh and West Bengal have done some sampling of surface water also.
As I said before, this is the dilution of water solution for arsenic. No, it's not.
No. It's for fluoride. For fluoride it is. For fluoride it is, but not for arsenic. Yes, after you pump that water out and keep it in a container or a tank or something and then add water, then yes. But then the quantities are so low, the concentration is very difficult to manage it.
Now I request Mr. Rajesh Srivastava, you may please ask your query. I request again Mr. Rajesh Srivastav, you may please ask your query. Sir, you just talked about the mass awareness, sir, and our next query is related to the, do you think awareness along with technology and infrastructure would also play a major role in this project?
Yeah, why not? Yes, it always mass awareness with technology and practical experiences definitely helps everywhere. We need to have a proper framework for everything. It will go a long way.
Incidentally, I had the IMG on the Interministerial Group for Arsenic Mitigation. This committee was constituted somewhere long back in 2016 or 17, and then the first meeting was held at that time, and second meeting I held recently after 5 years. Now, we have got members from various departments of the government of India, and many states were all represented in that. One concern which many people were raising was that the contamination of arsenic in the food grain, rice and all cultivation. Is that a major problem now? Because the groundwater pumped up and used for irrigation of agriculture fields, particularly in Punjab and Haryana, how do they have arsenic contamination in the rice?
So far in Punjab and Haryana, arsenic has not reached in the food chain. Otherwise, also Punjab and Haryana, arsenic is not of a major concern. But yes, I think in Bangladesh it had become an issue. I don't know about the status now, but yes, in Bangladesh and probably some parts of West Bengal, there was some problem of arsenic in the food chain.
So because I read somewhere that then the exported rice from India was rejected by US because of some contamination of rice. I don't know whether
I think I also remember reading something about it, but not from Punjab or Haryana, because Punjab, Haryana, by and large, arsenic free.
the export of rice was. It is not included in the food chain in India as such. That's what you're telling. So I think any more questions?
Sir, one more query left. This is from Mr. Ratin Badra, and his question is there any permanent solution for fluoride water or arsenic water? Do we have?
No, there is probably because the arsenic enrichment is taking place naturally. It's a geogenic issue. It's not a anthropogenic issue. So geogenic, I don't know how we can control a geogenic contamination issue. It's not really very feasible. And I think same with fluoride, unless until we have in situ remediation. But then again, that arsenic, where will the enriched arsenic sediments go?
So as you rightly said, the education awareness building is very important. So we had also returned to the state government and also the Department of School Education for of this arsenic awareness. So NIT, National Institute of NIH Roorkee also has prepared a module for inclusion in the studies. So Punjab, I remember they had said that 3,400 institutions they are covering through EduSat to make awareness about the students, and many other states also had actually started this education in and make children aware of the arsenic issue. So is that all? So it's very good topic we had discussion today and very high quality discussion. So thanks. I'll request our Sunil. Sorry, Tejdeep, आपका vote of thanks के लिए.
Thank you very much, sir. Thank you. First of all, it's my privilege to that I am being allowed to give the vote of thanks. And once again, thank you, MD sir, for conceiving a wonderful platform where the experts and the technocrats can interact with each other for the complex scenarios which are emerging in the field of groundwater, surface water, etc. My association with Sushil Gupta sir is more than 30 years old. So I have learned numerous things from him during my formative age in my service. In the early 90s, he was my direct boss at that time. I worked under him as a regional director. I worked under him as a chairman. So I got opportunity to learn so many things from him. Thank you very much, Sushil Gupta sir, for providing us such a wonderful insight on the one of the complex situations which is causing a lot of concern, particularly in the eastern India and Indo-Gangetic plain. As far as my experience and my knowledge goes, the arsenic contamination is very much prominent in Indo-Gangetic plain only. So there must be some reason behind it. और इस पर एक अच्छी स्टडी होनी बहुत जरूरी है जो सेंट्रल ग्राउंड वाटर बोर्ड फ्यूचर में कर सकते हैं कि why the concentration is more in Indo-Gangetic plain. Arsenic contamination has a numerous effect on the human population, as it is very dangerous for humans to consume arsenic contaminated water. Once again, thank you, sir, for giving us a wonderful insight and a wonderful insight in particular in Balia district. Thank you very much, sir. My sincere thanks to the team of Water Digest also for providing us the platform to interact with the experts and technocrats all over the country and across the world also. And last but not the least, my sincere thanks to the NWM team for creating an opportunity and doing a wonderful job for the successful completion of the 11th session of the Water Tech Talk. Thank you very much.
Thanks, everybody. Thanks, Sushil Gupta ji.
Thank you, sir. Thank you.
To remind you that on the next Friday, we have the third Friday coming up. We'll have the Water Talk.
Okay.
And from a water warrior from Hyderabad, she is Kalpana Ramesh. She will be talking about her experience of catching the rain in Hyderabad and restoration of many wells. Thanks a lot.
Okay. Yes. Thank you. Thank you. Thank you, Tejdeep. Thanks.